So the answer is no, that even with any of these restrictions, we still don't have a good definition. So let's consider all the restrictions. So the first one was if everyone is friends with Alice. So that would only work if they don't have any other friends. Let's say this is Alice. We've got Bob and Charlie. They're both friends with Alice, but Bob is also friends with Charlie, and Charlie is friends with Bob. That means that to figure out the popularity of Bob, we need to know the popularity of Charlie. To figure out the popularity of Charlie, we need to know the popularity of Alice as well as the popularity of Bob. So we're never going to get to a solution. We're going to keep bouncing back and forth between Bob and Charlie doing this. The second choice, only if no one is friends with Alice. Well, if no one was friends with Alice, that would remove these links. Doesn't solve our problem. We're still not going to be able to give a popularity score for Bob and Charlie. The third choice, only if there's a friendship path from everyone in the graph that eventually reaches Alice. So adding this link would provide that property, but it still doesn't solve our problem. It doesn't give us a way to figure out the popularity of Charlie, because to know that, we need to know the popularity of Bob, which we need to know the popularity of Charlie for. We still end up in this cycle. The final choice seems possibly more promising. It says there are no cycles in the graph. So if we want to remove the cycle, we could do this. In this case, we'd be okay, right? We could figure out the popularity of Bob by figuring out the popularity of Charlie, which depends on the popularity of Alice. Where we're not okay is if Bob has another friend. Let's say Bob is friends with Diana. Well, then to figure out the popularity of Diana, we need to know the popularity of Bob. Where it breaks down is, suppose we also have Diana and Edgar, and Diana's friends with Edgar. To figure out the popularity score of Diana, we need to know the popularity score of Edgar. We don't have a cycle, but we don't have an answer either. To figure out the popularity of Edgar, we're going to go through Edgar's friends. In the way the Python code is written, this could actually work, right? Because if we defined popularity when you have no friends, well, if the friends of P is empty, when we go through this loop, the score is going to be 0. So if you answered there are no cycles, that's at least worth credit for this. That could be correct. In terms of the mathematical definition, it doesn't make very, very good sense. We still need a way to know the popularity of Edgar. We've sort of defined things in this case to say if you have no friends, your popularity score is 0, and the Python code will work for that. But it's not a good way to define popularity. So it's very arbitrary to say we're going to make Alice the one whose popularity score is predefined as 1. There's nothing Alice can do to make herself more popular. That's not very fair to Alice. And it doesn't give us meaningful scores.